Good day, ma'am. This is the group presentation of Group 1, Team Galileo on electrode reactions during electrolysis. So what are electrode reactions and what is electrolysis? Electrode reactions are simply reactions which occurs with the absorption of electrical energy. And electrolysis is the process when ionic substances are broken down into simpler substances when an electric current is passed through them. So there are different kinds of electrodes, but usually they are metal plates with a surface area wider than a piece of wire connected to a power supply. The positive electrode is the anode that attracts anions, and the negative electrode is the cathode that attracts cations. So in the given example here, with the sodium and chlorine, which could be liquefied sodium chloride or salt, the electrode in the liquid chemical compound attracts the ions on both sides. The positive electrode attracts the chlorine, which is the negatively charged anions, and the negative electrode attracts the sodium, which is the positively charged cations. This attraction is simply because of the opposite charges. When the attraction occurs, an exchange of electron happens, which leads to a chemical reaction. Several things could happen. The chemical solution could form into a solid, give off gases, or turn into a different solution altogether. This variation depends on the type of liquid and as well as the type of electrodes being used. So about electrolysis. If a liquid solution contains free-moving ions or electrically charged particles, like in the example, it is called an electrolyte. And any chemical reaction resulting from the passing of electricity in an electrolyte is called electrolysis. So on to the kind of electrodes. The ion-ion electrodes. Many electrode reactions involve only ionic species such as ferrous ion and ferric ion. If neither of the electroactive species is a metal, some other metal must serve as a conduit for the supply or removal of electrons from the system. In order to avoid complications that would arise from electrode reactions involving this metal, a relatively inert substance such as platinum is commonly used.
Gas electrodes. Some electrode reactions involve a gaseous species, such as nitrogen, oxygen, or chlorine. A gas electrode consists of gas, bubbled about inert metal wire, immersed in a solution containing ions, with which gas is reversible. Platinum is used as conductor and to absorb the gas. An example is a hydrogen electrode, and the reaction represented as shown below.
Insoluble salt electrodes. A typical electrode of this kind consists of a silver wire covered with a thin coating of silver. It is the most common type of electrode where a metal is in equilibrium with a solution containing its ions. Although the usefulness of such an electrode may not be immediately apparent, this kind of electrode finds very wide application in electrochemical measurements. Reference electrode. The major requirements of a reference electrode are that it be easy to prepare and maintain, and that its potential be stable. The last requirement essentially means that the concentration of any ionic species involved in the electrode reaction must be held at a fixed value. The most common way of accomplishing this is to use an electrode reaction involving a saturated solution of an insoluble salt of the ion.
Reactions in some commercial electrolytic process. Electrolysis has various applications in our day-to-day living. Below are some of the commercial applications of it, including how these electrolytic processes react. There are three kinds of commercial electrolytic processes. The first one is the electrorefining of copper. Second one is the electroplating, and the third one is aluminum production. In electrorefining of copper, electrolysis can be used for purposes other than preparing elements. One example is the refining of copper. Very pure copper is often required in the manufacture of electrical equipment. A purity of 99.999% is not unusual. The easiest way to produce a product of this purity is with electrolysis. An electrolytic cell for refining copper contains very pure copper at the cathode, impure copper at the anode, and copper sulfate as the electrolyte. When the anode and cathode are connected to the battery, electrons flow into the cathode, where they combine with copper ions in the electrolyte. Pure copper metal is formed on the cathode. At the anode, copper atoms lose electrons and become copper ions in the electrolyte. Overall, the only change that occurs in the cell is that copper atoms from the impure anode become copper ions in the electrolyte. Those copper ions are then plated out on the cathode. Any impurities in the anode are just left behind, and nearly 100% pure copper builds up on the cathode. The second one is electroplating.
Electroplating. Another important use of electrolytic cells is in the electroplating silver, gold, chromium, and nickel. Electroplating produces a very thin coating of these expensive metals on the surface of the cheaper metals, giving them the appearance and the chemical resistance of the expensive ones.
In silver plating, the object to be plated, a spoon for example, is used as the cathode. A bar of silver metal is used as the anode, and the electrolyte is the solution of silver cyanide. When this arrangement is connected to the battery, electrons flow into the cathode where they combine with silver ions from the electrolyte to form silver atoms. This silver atom plates out a thin coating on the cathode, in this case, the spoon. At the anode, silver atoms give up electrons and become silver ions in the electrolyte. Silver cycled, therefore, from the anode to the electrolyte to the cathode where it is plated out. The third one is the aluminum production. In year 1886, Charles Hall and Paul L.T. Helcourt discovered that molten cycrolite, a sodium aluminum fluoride mineral, could be used to dissolve alumina, that its resulting chemical reaction would produce metallic aluminum.
Charles Hall and Paul L.T. Herold found that by passing electrical current through cryolite alumina mixture, they could bring about a chemical reaction that converts the alumina to metallic aluminum. The Hall-Herold process, as it is known, remained in use today. Aluminum ore is called bauxite. The bauxite is purified to produce aluminum oxide, a white powder from which aluminum can be extracted. The extraction is done by electrolysis. The ions in aluminum oxide must be free to move so that electricity can pass through it. Aluminum oxide does not dissolve in water, but it does dissolve in molten cryolite. This is an aluminum compound with a lower melting point than aluminum oxide. This is electrolyzed to produce aluminum metal at the cathode and oxygen gas at the anode.